Hey everybody, this is Matt with mathsmath.com. Thanks for joining us here as we talk about how to graph linear inequalities. Moving on to something different here, talking about the functions of the Common Core Math Standard. We're going to define, evaluate, and compare functions. Today we're going to be looking at inequalities and how to graph inequalities. So that's going to be our questions. How can we graph inequalities using two dimensions? In the past we've looked at inequalities with just one dimension, with just filling in a dot and then shading in the line left or right. Now we're going to talk about how to do this on a coordinate plane. All right, it's going to look something like this. Look at this graph down here. All right, a little bit unusual, huh? This looks like our normal x and y coordinate plane. And then notice we have a line here, but it's dotted, and then we shade below it. Those are the two things we're going to be looking at here today. And so let's get started. Almost but not quite. You know what? When we're graphing inequalities, it's kind of almost, but it's not necessarily a strict answer like we've seen in the past. With an y equals mx plus b line, every point on that line is an answer. But with an inequality, everything in that area is an answer, as opposed to just one specific line or point. Okay, so let's look at what this would be. If we were to graph y equals x, this is what it would look like, right? Nothing new. Y equals x, our slope-intercept is 0, hits at the origin there, and our slope is 1. So we're up 1, over 1, up 1, over 1, up 1, over 1, and so forth. Now let me show you what it looks like to have y is greater than or equal to x. Not just y equaling x, it's y is actually equal to x and greater. So what we do, ignore the greater than sign first, and then just graph y equals x. That would be my suggestion, okay? So here you've got y equals x. It's the same line we just looked at. I made it a little bit thicker just for emphasis. And then every point above it is where we do the greater than sign. So now y is greater than x. Well, where is y greater than x? Everything up here. And if you ever have any trouble with this, my suggestion is this. Pick a point somewhere in here. Okay, pick a point somewhere in here. Let's just pick 0, 2. Okay, my point right here is 0, 2. Now, plug it back in the equation, the inequality rather, and see what happens. Well, my x is 0, my y is 2. Is 2 greater than or equal to 0? Yeah, it is. So that's where you shade. Does that make sense? Whereas if I'd come down here and I'd pick the point negative 2, or 0, negative 2, plug that in, see what happens? We would get negative 2 is greater than or equal to 0. What about that? Is negative 2 greater than or equal to 0? No, it's not, so we don't shade down there. Does that make sense? So plug in a point if you're ever confused on how to shade, whether it's up or down, left or right. Usually it's pretty easy to know that when y is greater than, you go above the line. When y is bigger, you go above the line, okay? Here's our next one. Well, you can imagine when y is bigger than, you go above the line. Well, when y is less than, you go below the line. Does that make sense? Again, we've just graphed it y equals mx plus b style. Bam, there's the line, and then we're going to shade below it. And again, if you want to take a point, plug it back in and see if it works. That'll tell you where you shade it. Now what happens when you don't have that equal sign underneath there? Notice that the equal sign's not there. This is just y is greater than the x. Well, we still graph it y equals mx plus b, but notice I make it a dotted line because that represents that I can't actually be on the line, right? If I were to plug in 0, 0, 0, is 0 greater than 0? No, it's not. So we do a dotted line there to show that that's the boundary. It actually isn't on the y equals x graph, but it's above it. Again, y greater than x, so it's above it. Again, if you have any trouble, plug in a point to the specific equation, inequality, and see what happens. And then you can imagine here, same thing. Y is less than x, there's no equal to there. It's a dotted line on the y equals x line, and then we shade it below because y is less than x. Okay? Not too bad, huh? Finally, you get to color in math. Pretty cool. All right, so let's talk about how we graph inequalities. This is just the basics of it, okay? When it's greater than, it's dotted, it's a dashed line, and you shade above it. When it's less than, it's a dotted line, and it's below the line. And then when it's greater than or equal to, it's a solid line, and you shade above, and it's less than or equal to, it's solid, and you shade below. Does that make sense? Pretty basic. Make sure you write that down though, because that's something that you'll need to know, okay? So let's talk about this. Let's look and see if these are solutions to the inequalities. Just like before, I asked you to pick a particular point and see if it solves it. This is what we're going to do now. So we take 3, negative 1. Well, that's my x, that's my y. You take 3, plug it in. Does it work? Well, let's see. Plug in the point. We get negative 1 is the y, 3. So it comes out to be negative 1. Is negative 1 greater than 1? No, that's false. So it's not actually a point. It wouldn't be in the shaded area. Does that make sense? This point would be outside the shaded area because negative 1 is greater than 1. All right, let's do this one. What about point 1, 0? Well, plug in the 1 for x, the 0 for y, like we've got down here, and see what happens. So then we get 0 is the y, plug in the 1, we get 5 times 1, which is 5, minus 3, which is 2. Is 0 less than or equal to 2? Yeah, that's true, isn't it? So this point, 0 or 1, 0, is inside the shaded area on that inequality. Why don't you try these guys? Plug in these points and see if they're in the shaded area or not. Negative 1, 6, and negative 4, negative 5. All right, did you have any trouble with it? Watch your negatives here. Check your negatives. Same with this one. Well, number 3 was negative 1, 6 is a solution, and so is negative 4, negative 5. They are both solutions. They both fall in the shaded region on the graph, okay? Now, would you take a minute and once you graph these? We got y is greater than 4x, y is less than or equal to x plus 1, and so forth. Again, you want to make sure that they're in the y equals mx plus b form. This one's not. And ignore this first. Okay? Ignore this. Graph this as if it was y equals 4x. Y equals 4x. And then notice, come back and say, hey, it doesn't have the line underneath, so it's going to be a dashed line. And it's y is greater than 4x, so it's y is above that line at 4x. So you're going to shade above. This one, shade below, and it's a solid line. This one, you got to move everything around, okay? Do that first, and same thing with this guy. It's got to be y equals, or y is less than or greater than or equal to, okay? Here we go. So let's do this one together. Y is greater than 4x. Well, easiest way to start is that slope-intercept form gives me a y-intercept of 0. We go over 1, up 4, down 4 over 1. So this is our new line. Okay. Bam. There's our line. All right. And I'm going to now, what I like to do is I'd like to just come in afterwards and erase it. For me, that's a little bit easier. So bam, bam, bam. Does that make sense? So erase it rather than maybe drawing a dotted line at first. That's easier for me. I just find that more helpful. Okay. Now it was y is greater than. So then what do we do here? Do we shade above it or below it? Any idea? We shade above it because it was greater than, and let's start doing that. So then what we do is we take our little spray paint, bam, spray it above it, and that's your graph, okay? See, like I said, this is the first time you get to color in math. Pretty sweet, besides doodling when your teacher's not looking, huh? Bam, there it is. Looks like that graph's on fire. All right, cool. Why don't you try these other guys? Why don't you try y is less than or equal to x plus 1. Remember, dotted, shaded above, shaded below, solid line. Look for all those things, okay? Easiest way to do it is ignore this sign first and then just graph y equals x plus 1. All right. Well, Juan's taking a trip and he has $1.25 to ride the bus. He puts in X amount of dimes and Y amount of quarters. Write an inequality of how much he could put in the machine and then graph it. Now, how much did he have? He had $1.25, right? He puts in X amount of dimes and Y amount of quarters. All right, if you're having trouble with this, definitely think about how much a dime is worth and how much a quarter is worth, okay? If you think about it, he's got $1.25, right? Well, he can only spend $1.25. So it could be equal to $1.25, or this other side is going to be less than. It's going to be greater than symbol here, but this side is going to be less than that, okay? So then what we're going to do is he has X dimes. Well, how much is a dime worth? 0.1x. And then how much is a quarter worth? 0.25y. Does that make sense? Because this is the amount per dime, how much it's worth, and this is an amount, 0.25, how much y is worth. So now, again, solve for y, bring everything over, get away from y, switch it around, and then you're going to graph it. All right, you put it on a graph, and this is what it's going to look like, something like this. Here was your first one, second one, third one, fourth one, and then it's going to be something like this. So all the possibilities, all the whole number of possibilities here inside this shaded area are the amount that he could actually have had of dimes and quarters. Does that make sense? It opens up a lot of possibilities now. You have a lot more answers than you did before than just a straight line. Pretty cool, huh? Well, that's it. Can you answer this question now of how you can graph inequalities using 2 dimensions? I bet you can. This opens a lot of cool things here in the future with math. Well, this was Graphing Linear Inequalities. This was Matt from mattsmath.com. Check us out on Facebook at Solving Maths Problems, or on Twitter with Matt's Math. And enjoy math and riding the bus.